Okay, so we continue with nonlinear PDE. Now, for a PDE to be nonlinear, then these conditions, one of these conditions is true, or all of them are also true. So the first one, we talk about the power rule, saying that if the function u or its derivative are raised to any power other than 1, then it is nonlinear. So for instance, if I have ut to be equal to k u x x plus u square, for this equation, as soon as I see that the unknown function u is raised to any power, I just conclude that this is a nonlinear PDE. That's using the power. And then secondly, we can also use so this one we are looking at the power rule. Now, the second thing we also note is that if the function u is multiplying itself, or it is multiplied by its derivative, or the derivative is multiplied by each other. For instance, we have, let's say, u t plus u times ux to be equal to 0. In this equation, you can see that the unknown function u is multiplying its derivative, and so this one too disqualifies it as, or qualifies it to be a nonlinear PDE. So this one, we call this one cross multiplication. So cross multiplication, when it comes into your head, you say it is when the unknown function is multiplying each other or its derivative or itself. Yeah. And then the third one we'll consider is when it is found in, when there's a function like the sine function, the cos function, the logarithmic function, and then the exponential function. If it contains the unknown function, then it is also a nonlinear PDE. So for instance, if we have utt minus uxx plus sine u equal to 0, in this case, you can see that the sine function contains the unknown variable or unknown function u, and so in that case, this whole equation becomes a nonlinear PDE. All right. Now we have types of nonlinear PDEs. As any PDE can be, if it is nonlinear, if any of these conditions is met, it is nonlinear. We can also still classify nonlinear PDEs into 3. So types of nonlinear PDE. All right. So we have 3 types. We have one. We'll consider the semilinear PDEs. Semilinear PDEs. Okay. So what is a semilinear PDE? Semilinear PDE, this is when the highest derivative is linear. The highest derivative is linear, and their coefficient depends on only the independent variables. And their coefficient depends on only the independent variables. So 2 conditions. One, the highest derivative is linear, and then secondly, the coefficient of the highest derivative is the independent variable. It's only the coefficient is only the independent variable. All right. So that's for a semilinear PDE. Now, every semilinear PDE has a form. So if it is in the first order, it has a form a x y u x plus bxy uy equal to 0. As you can see, the coefficient of the derivative is axy and then bxy. That is, it depends on only the x. And then in second order, we have axy uxx plus bxy uxy plus cxy uyy equal to d of x y ux uy. So as we can see, if we have any of this form, if it is semilinear, it means that the coefficient of the highest derivative, these are the highest derivative, uxs, uxy, and then uyy, they are all in the second derivative. Now the coefficient depends solely on the independent variable. An example of a semi-linear PDE is when we have ut minus uxx to be equal to u squared. Already, this u squared makes it nonlinear, but as to what type of nonlinear PDE it is will depend on the highest derivative. And the highest derivative here is uxx. And then the coefficient of the uxx is 1, which is the independent variable, actually. So in that case, we can say that this is a semi-linear PDE. The next one we'll talk about is the quasi-linear PDE. So the second one is quasi-linear PDE. The quasi-linear PDE. So for the quasi-linear, these are non-linear PDEs in which the highest coefficient or the coefficient of the highest order terms are of the independent variable. So the conditions: one, the coefficient of the highest order derivative are functions of the dependent variable, and then or it can be the derivative of lower functions of the lower unknown function, so or lower derivatives of the dependent variable. All right, so as we can simply explain this one as, if it is quasi-linear, it means that the coefficient of the highest derivative is either the dependent variable or the lower derivatives of the dependent variable. We should get it clear. It should be clearer that if we have a nonlinear PDE, for instance, if I have u, so an example, so if I have ut plus uxx equal to 0, in this our case here, we can see that the highest derivative is this one. Now, the coefficient of the highest derivative is the unknown or the dependent variable. And so, in that case, we can classify this one as a quasi-linear PDE. All right, so that is that. And then the last one we will consider is the fully nonlinear.
All right, so with the fully nonlinear PDEs, the highest derivative is nonlinear. For example, if you have uxx plus uyy and uyy squared equal to 0. In this case, our highest derivative is 2, right? That is uxx and then uyy. But the highest derivative here, one of them is squared, and so this one becomes non-linear, fully non-linear PDE. And then also, if there's a function, the sine function, the cos function, the exponential, and the logarithm function contains the unknown variable or unknown function, we say that that one too is fully nonlinear. So an example is, if I have ux plus e raised to the power u equal to 0. In this case, you can see that the exponential is carrying the unknown function, and so in this sense, we'll see that this is also a fully nonlinear PDE. All right. So I have a table here, and so let's try and see. So you can pause the video and then try your hands on it, and then we solve it. So if we pause the video, let's see the first one: cos x ux plus uy equal to u squared. Now we know that it is nonlinear based on the u squared here. And so what type of nonlinear equation is this one? You can see that the coefficient here is of the independent variable, and here the coefficient here is only 1. So since it is only the independent variable, that is the coefficient of the highest order, we can say that this is what? Semi-linear. So semi-linear PDE. Then the second one too, the highest order here is UTT and then USS. Now the coefficient of this one is 1. The coefficient of this one is U, which is a dependent variable, or this is the dependent variable multiplying that. And so this one gives us a clue that since it is multiplied by the dependent variable, we can say that this one is also quasi-linear. Quasi-linear. And then the third one, looking at the coefficients, here we can't see any nonlinear term because the coefficient here is 1, the coefficient here is the independent variable, and then the coefficient here too is, or the function here is and the independent variable, which doesn't contain the unknown function. So in that case, we can say that this one, everything is perfect, and so this one is a linear PDE. And then the last one, we say ux minus sine uy equal to u. Now, as we can see, the sine function is containing the unknown function, and so in that case, we can say that this one is fully non-linear. All right, so that is that. If you like this video, please like, share, and then subscribe to my channel. Till we meet again. Bye bye.